Welcome to this video. We are going to look at Coulomb's law of forces, a tutorial question. The question is saying that two charges, Q1 3 times 10 to the power negative 8 coulombs and Q2 negative 4 times 10 to the power negative 8 coulombs are separated by A, which is 6 times 10 to the power negative 3 meters, as shown, supposed to be as shown there below. What is the force of what the force of one should be on one charge, force of one charge on the other? So they want to know the force Q1 is exerting on Q2 and the force Q2 is also exerting on, well, Q1. Okay, so what are we going to do? All right, let us recall Coulomb's law. Okay, let us recall. All right, so we know the force is given by what? K, but for us, because we need to find the exact value, well, it's fine. You can say K, okay, K. Then we have charge 1 multiplied by charge 2, like the magnitude. We divide by the square of the separation distance between the two charges. Okay, it's very simple. K is a constant, usually given in exams, which you don't have to worry. Myself, I have it. We are going to use 9.0 times 10 to the power 9. Okay, it is usually given in units as Newton meter squared over C squared. C is actually for Coulomb. Okay, we are multiplying what? Q1. Q1 is 3 times 10 to the power negative 8 coulombs. And Q2 is, now remember, we are taking magnitude. So the negative is already dealt with. That's why I had to put these bars. So I'm only going to put 4 times 10 to the power negative 8 coulombs. And not the negative. We are interested in the magnitude only. Okay, so we are going to divide everything. Okay, so we can say that, okay, R squared is this, which is 6 times 10 to the power negative 3 meters, okay, squared. The only thing that we need to do, ladies and gentlemen, is to punch this on the calculator. So I'm going to have this. Let me first punch this. Okay, so we have 3 log negative 8 multiplied by 4 log negative 8 divided by, open brackets, 6 log negative 3, then we square that. So I'm having something like 3.33 times 10 to the power negative 11. So I'm going to multiply this by 9. 9. And it's giving me the force of 0.30 newtons. So this is the force, all right? Each of these charges is actually exerting on each other, okay? But one thing that you need to understand is that Q1 is positive and Q2 is what? Is negative. Do you know what that means? This means that the force is actually directed from one to another. Now remember that charges usually move positive to negative, meaning this is negative, this is positive. Okay, and charges move from positive to negative. Okay, so charges are now being directed, sorry, not charges, but the force is directed from one to the other along the same. So this guy exerts the same force and that guy exerts the same force. This is what you need to know. Okay, it's very interesting and it's simple as that. We will keep on looking at more complicated problems, but for now, shalom.